Please allow me to introduce our fifth speaker, Mikołaj. Please correct me if I pronounce your name incorrect. Mikołaj, he is the CEO of Scanway Space. Please, are you there? Yeah, you
Yes,
can.
I am.
Yeah, please, you
Thank
can
you,
share your
Abdullah. Yeah,
screen.
for the
Yeah, there you
introduction.
go.
Hello, everybody. Let me just share my presentation. 1 second. And it should work now. Can you please confirm that you can see the presentation?
Yes, we can
Okay,
see it.
perfect. So as Abdullah mentioned, my name is Mikołaj Podgórski. I'm COO of Scanway, but Mikołaj will also do. I mean, any sort of my name will work in English. It's Nicolas as well, so whatever suits you, it will work. I'm a COO and responsible for the space business development activities that we have at Scanway. And the goal of today for me is to present you with some of the latest updates that we have, which are more or less related to the oil gas sector. And mostly, since we are doing optical payloads, they will be related to the environmental monitoring of specific parts of the world. But before I get there, let me say a few words about the company because we are not a startup anymore. 8 years on the market, actually 9 almost. In January it will be 9. We are a publicly listed company in Poland. So it's something. It's not US, but it's still something which boosted us really much. We have TRL9 obviously on our products. 7 of them were already sent to space. We have, I think, like 5 more, maybe 6 that should be sent somewhere in between tomorrow and the end of the next year. So it's quite intense. And we have more than 60 people on board, and we have our offices located in Poland, here in Wrocław. And also we have some small US branch which is helping us to conquer this market. And what we are doing is optical payloads for different remote sensing applications. We call them SOP. We also do different sort of cameras for the, let's say, rendezvous and docking and proximity operations or deployable monitoring, but I'm not gonna focus on that since it's not really relevant to the topic of the discussion of today. In terms of the optical payloads, we obviously design, we develop, we subcontract manufacturing, we do the whole testing, integration, and assembly stuff. We calibrate everything, we test everything, and we also, which is not really that much obvious, we help with the operations when the payload is in orbit. It's quite tricky because with optical payload, it's not like with the telephone. You cannot usually just set the autofocus on and not worry much about the rest. We have to really set up the good parameters of the solution. And speaking about the payloads, we do different stuff which is suitable for small sats, like one new nano satellite payload up to something which is like, dedicated to 100 kilogram platform and more soon. And what is connected to today's topic of the session of the webinar is everything that we are doing in shortwave infrared. So not in the visible spectrum where we can see, images from cameras which are easily like similar to things that human naked eye can see, but the shortwave infrared, which is let's say something that we cannot see as humans. And why we've seen some time ago that there is obviously bigger push towards having better monitoring of the CO2 and CH4, which is absolutely critical for the oil and gas industry and in the end for all the, let's say, heavy manufacturing industries all around the world. We have in European Union, but not only, we have all those systems with fines for the exceeding the specific limits of the emission of CO2 or CH4 as well. So we see that there is this huge push for this environmental monitoring. But honestly speaking, there are still some problems with the technologies which are needed to really achieve those observations. I'm not really talking about, old space, big agency projects which can actually, build everything with the huge amount of money. I'm speaking more about the new space approach, where you have limited budget and you have the will to increase the risk. So we don't really have the full technology to observe everything at once. The full technology that would be with reasonable pricing. So what we have noticed is that for observing the CO2 and CH4, it would be good to have sensors in optical payloads which are currently not available. Like, the sensors that would be available are costing like 300k euro per one sensor with minimum order of quantity of 30 pieces. So it's like a little bit too much to handle for the small satellite, paying, let's say more than €500,000 per sensor only, not to mention the whole optical system, not to mention the mechanics, the rest of the electronics. So that's why with our current partners, with what we are doing, we focus only on the wavelengths which are up to, let's say, more or less 1.7 microns. We see that it is actually working because one of the companies, which is actually the state of the art now, so GHGSat, they are measuring the CO2 and CH4 in the wavelength of between 1.6 to 1.7 micrometer. So it's working. But the problem is how to actually make a business case out of it. And before I speak about that, one last remark which I wanted to show to really present why it's a technological problem. Don't mind the text on the left, just let's focus on the graph on the right. We see here the quantum efficiency, or in this case the relative response, so the efficiency of the sensor with relation to the wavelength. And we can see that those, let's say, normal, available with reasonable pricing sensors, they have this cutoff frequency at around 1700 nanometers, which is enough to observe CH4, but it is not really enough to observe CO2 with very nice and very good accuracy. So after doing this research, we have started a project which is funded by Korean bank and customers from Korea mainly. So the project itself is called NARSHA project. There we have the involvement of Seoul National University, as of course as Scanway, and the project is led by Nara Space Technology, so the company from Korea, which aims at really developing finally a constellation of 60 new CubeSats that will be able to monitor the methane emissions. Firstly, in East Asia and in Korea, not necessarily in Europe at the first place, which is kind of, let's say, interesting for us because somebody else would take a lead here in the area of decreasing of the greenhouse gases emissions. But anyway, the aim behind that is very simple. Everybody wants to know how those methane emissions look like, finally. How to really do some fine systems, but to do so you need to really have a third-party independent monitoring solution. So that is our role in the project. We are obviously not touching the satellite at all. We are developing the payload for that, which is like, let's say, more or less in line with what I presented in the last slides. It's gonna fit the 16 new CubeSat. It's going to fly in 2026, so not that far away from now. And the idea of the whole, let's say, observation is to monitor some specific parts of the country with the use of our hyperspectral payload with forward motion compensation that is increasing dramatically our performance. We will be able to see some specific thresholds on the methane emission rates. I will not disclose any numbers actually because that's not yet fully public with what we can do. But anyway, the goal is to be able to distinguish the single production plants and to see what the emission looks like from different sources. And it's quite important for us because it opens the new possibilities and these kind of monitoring sources, which are obviously some kind of a competition to the GHG-SAT and Satlantis. So these kind of satellites can be used as for now for the CH4 monitoring, but in future when the technology is, let's say, when the sensor technology is ready to meet the new space budget limitations, then we can obviously use the very same product and combine the CH4 with CO2, which would give us very big, let's say, exposition to all of the global players who are really, like processing any type of materials and emitting the CH4 and CO2, especially the oil and gas sector. We've had so far some huge interest from the, let's say, Central Asia and East Asia customers who would like to have this data available when it flies. So hopefully it's gonna happen. And just to sum up, because I see that my timer is just hit 11 minutes. Why 16U? Why so small satellite? Because those sensors which I mentioned, which are, let's say, available for the new space players, they are quite small. So it's either great GSD or big size of the image. And we have selected the second choice. So we want to have a very huge image that would allow us to really capture a lot of potential, power plants, factories, oil and gas plants, or stuff like that, taking into account that we are using the optical payload, meaning that the clouds will be a problem. That is a good solution. And of course, the 16 new CubeSats are, let's say, quite affordable in terms of the pricing for launch and for the satellite platform. Another thing is that right now, lots of people are talking about the shortwave infrared, but in the end, it's not really that well known among the end users of the images. So everybody now wants to have a shortwave infrared payload, like they used to want a hyperspectral camera, but there are not really that many options of what you can do with that data, and people need to understand what exactly can be done. So starting with some small missions like that, it's also a good way how to build the knowledge among the end customers. And that would be all. Thank you very much for the attention. In any cases, I encourage you to reach out to me over the email or on LinkedIn. Thank you.
Thank you, Mikołaj, for this amazing presentation.